All right, we're going to talk about dilations on the coordinate plane today. We've been off the coordinate plane for a couple days, but now we're going to go back to the x and y axis. So what we saw in the first two lessons is that when you scale or dilate, the figure is going to get larger or smaller. And the scale factor determines this, and it keeps everything in proportion. So if my scale factor r is 3, what happens to the sides of the figure? And hopefully you'll say, well, they're going to triple, right? Each side is going to triple in length. Everything gets multiplied by 3. If my scale factor were 1/2, then they would be halved. All the sides are cut in half. And then what happens if r is 1? If my scale factor is 1? And hopefully you realize that all the lengths remain unchanged, so they don't get bigger or smaller. So when you think about it, what operation will triple something when my scale factor is 3, or have it when my scale factor is 1/2, or doesn't change it at all when my scale factor is 1? And hopefully you've realized that we have to multiply distances by a scale factor when we are dilating. So here's our general rule. When we are on the coordinate axis, capital D stands for dilation, and O stands for the origin. And then sometimes, we use an R for a scale factor, but we also can denote it with a K. So you'll see both things in class. So when my scale factor is K, that ends up as K times X and K times Y. You multiply both coordinates by that scale factor. So we'll model this with a few exercises here. Again, the process is just multiplication. What are the coordinates of the image when I start with 2, -4, and my dilation is 0, 2? So my scale factor is 2. This is just the origin. So O is the location of the origin, and I'm going to multiply both numbers by 2. So I end up with 4, -8 for that one. The next one, I have a dilation of 1/3. That means my numbers are going to shrink, and they're basically divided by 3. So if I start with 9/15, I end up at 3/5. For the next one, I want to find the scale factor that maps -4/6 onto -16/24. For dilations, the relationship has to be the same, so I have to multiply the -4 by whatever number to get -16. I got to multiply 6 by the same number. So -4, I guess if we worked backwards, -16 divided by -4 is going to be +4. So my scale factor, I'm about the origin, I'm scaling these things by 4, and we can check with the other value. 6 times 4 is +24. So that's what my notation looks like. So let's go to the next one. I want to map -4/6 to -10/15. Well, I start with the image point, not the pre-image. If I start with the image and want to find the scale factor, I take that -10 and I'm going to divide by -4. Reduce down, that's equivalent to 5/2. So I think my dilation is going to be using 5/2. I can check with the second point. So the second point is 15, going to divide by 6. So here's my check. 15 divided by 6. If I reduce the 3 out of both of those, I do end up again with 5/2. So that checks out. So now we're going to graph a little bit. I'm going to graph triangle NAP, and here's my vertices. We'll do that first, and then we will apply a scale factor of 1/2. Everything's going to be dilated from the origin. So again, the process is the same. You're just going to multiply all of your coordinates by the 1/2. But first, let's graph triangle NAP. So 2 and 8 is N. If I can put him on here, there's N. A is at -6, 0. So there's A. And P is at 4, -2. 1, 2, 3, 4, -2. So there is triangle NAP. That's the original. Now I want to graph and state the coordinates. So I'm going to write the coordinates on the side to make sure I have them, of n prime, a prime, p prime. And I'm going to get this by scaling everything down by 1/2. So n prime is, if I take 2, 8 and cut it in half, that's 1, 4. A prime, if I take negative 6, 0 and cut it in half, that's negative 3, 0. And p prime is going to be 2, negative 1. Now I can graph these guys, 1, 4, and what you will see is an image that's scaled down from the original. So there's n prime. A prime is negative 3, 0. There's a prime. And p prime is 2, negative 1. There he is. So there's my scaled image. If you were to measure the side lengths, you would see that AP is going to be twice as big as A prime, P prime, because everything is scaled to the same factor. The coordinates create the sides that are scaled down by half. We're going to finish with an example of a composition. I've graphed ABC. These are the coordinates for ABC. And I want to graph and state the coordinates of the double prime. And that's a result of the composite transformation of the translation and a dilation. So if you look at your composite function, remember we have to work right to left. So I'm going to apply the translation first and then the dilation. I'm going to try to apply the translation rule to my 3 coordinates. So if A is 1, 3, then A prime under that translation is going to be, I'm basically adding 3 to x and subtracting 2 from y, so that's going to be 4, 1. For B, for that translation, if I start at negative 2, 2, I'm going to end up at 1, 0. And then for C, if I start at 0, negative 2, I should end up at, let's see, 3, negative 4, if I did that right. So now we'll graph those points just to double check. So A prime, and I'm not going to draw the entire triangle, I'm just going to graph the points to see if I did it right. So there's A prime. 1, 0 is B prime. That looks right. And then C prime should be 3, negative 4. So if you look at that, it should look right, because if I were to draw this triangle, it looks like he's shifted this way and down, just like our translation said. So now we've got to take these points, and we're going to write the final coordinates. So this is a dilation of 2, so everything's going to double. A double prime is 8, 2. B double prime will be 2, 0. And C double prime is going to be 6, negative 8. So I'm going to graph that. Let me try to pick a different color. Let's graph that in purple and see where we go. So A double prime is going to be 8, 2. I'm taking the red and I'm dilating it by 2. B double prime is 2, 0. So here's A double prime. I got to label them. And B double prime. And then C double prime is 6, negative 8. So everything gets doubled. And there's my final triangle. Okay, he's dilated after he's translated, and you'll see that he's twice as big as the original. So we'll practice more of these in class, and we'll definitely practice the composite functions too, to give you more practice with doing this and remembering the order. You're always working right to left.